Hey there, this is the Vulnerability Collapse Exercise 2 Double Free Solution Guide. So this challenge is very similar to before, and I hope you guys were able to get it. Just like before, I'm also going to show this graphically first with nice diagrams, and then after that, I'm going to go through this in GDB to get a better feel of what's going on. So just like before, I'm going to turn off my camera. And we're going to allocate a player to begin with. After we allocate the player, we're going to free it. And this is just like the first two steps are exactly the same. This is going to put a chunk into the T cache. The difference now, though, is I'm going to free/delete the player again. And this will put a chunk into the T cache again. Now, we have the same chunk in the T cache multiple times. So if we make two allocations, those chunks will overlap. So on the first allocation, we're going to allocate to the player structure. And this still leaves a single version of this within the T cache itself. Now, if I allocate one more to the P array, it's going to have the same effect as before, where it's going to allocate a chunk of size hex20. There's going to be two pointers pointing the same memory. And this is going to lead to the same overlap situation as before as well, where the player structure is being used, and it's going to point to the same memory as the P array. So the 103 will once again overlap with the 25 of the score. Again, this is because we started with two chunks in the bin. We allocated one for the player. So now this has a pointer to, or this has one chunk. But then when we call allocate for the player struct, it's going to use the same exact structure. So we have that overlapping effect where two pointers think that they own the same memory, even though they're both using it for different purposes. So to recap on that, we create a player. We're going to delete the player again, create a player, play, and then we're done. We win at that point. So now I'm going to show this looks like in GDB. If I could type. So we're going to do this first two steps just like we did before. We're going to do malloc with my name, and then we're going to do free. So right here, we're going to look in the bins. In particular, we'll look at the Tcache bin. Tcache bins. There we go. And that looks fine. I need to go back down. There we go. Okay. So now I'm going to call use, and of course that's not going to work. So we have to do something else instead. This time I'm going to call free again. And this is the second time it's been freed. So if we look at the Tcache bins, we'll notice that this same chunk is now in the bin twice. And that's where we get this double free from. So if we go back up and we call malloc, go down, and we look at bins once again, we'll see that this chunk is still there, but the player structure has the same pointer to it. 260, 260. So all we have to do is call play this time. I need to continue this right. So now if we call play, or use, it is then going to use that pointer, write to it, and then free it. And just like before, where it wrote 103 to the score value, if we do 1, we get the flag. If we go back down here, we print out the dereference version of the form player, we can see that this is indeed 103, just because of that write we did. So again, to recap, I'll go through the diagrams just to make it easier. We allocated a player, we freed the player, and put this in the Tcache bin. We then did the same thing and put two chunks into the Tcache bin. After doing that, we allocated the player so that we had a reference to that pointer. and then we allocated the p-array, which acts as our overlapping chunk. Now that these two chunks are overlapping and they write over the top of each other, it creates a use after free like scenario via the double free. Great. Well, I hope this exercise went well for you and you have a better understanding of double frees and use after frees after this. This one was a little bit more complicated, but I'm confident you can do it. Good luck in the next stuff.